Okay, so we're going to try to do math problems in Blender here, and this will be my first attempt at doing this, so bear with me. But if I start a new scene over here in the new scene, and you'll be able to see what I'm trying to get at. If I start a new scene and I'm in this scene, and basically I want to add a reference image, and the reference image that I'm going to use is going to be the math, where I have math in documents, math problem images. So I have this image here, and let me zoom in on it so you can really see it. So this is a classical textbook image for trigonometry, and it's about the angle of the sun. So I set that as my reference image. And then I would go into object mode and add a plane, a mesh plane. There's my plane, and I'm going to set that, and I'm going to try to replicate the triangle that they have. And the way I'll do that is I'll go from that plane into edit mode, and I'll grab this one vertex and drag it along the x-axis, so GZ, and bring it out to there. And then I will also, let me think this through. No, I don't want to do that yet. I'm going to undo that. The first thing I want to do is, first thing I want to do is to go to edit and select everything, and I'm going to subdivide by right-clicking. And is that the best way to do it? No, that's not the best way to do it. Let's see, if I take this vertex and this vertex, here's the way to do it. And then right-click and say connect vertex pairs. Now I have a line. Then I can take the top part of this triangle, that one vertex, and delete it, and now I have a triangle. All right, so now that I have that triangle, I'm going to select that triangle, and I'm going to go to Object and set the origin to geometry. That's that little orange point there in the center. That's if I wanted to now rotate it, it would be rotating about that center point, so that was very important to do. Now I'm going to go to the object, to edit mode, from object mode, grab this vertex, and then move it by hitting G and X and drag it over to where it is in the diagram. And then do the same thing for this vertex here, G and Y, and bring it down. So now I have, as you can see, I have clearly, I'm using this different viewport shading from transparent or wireframe to there, I have the triangle that more or less matches the image, and you can play around with that a little bit if it's not perfect. Let's move that up a little bit in Y and move this back in X. And in fact, we should look at the properties of this under item and see that we have, see how these change. So make sure that this value in X, copy that, is the same as this value here. It wasn't. So now these are right on top of one another, so it's perpendicular. And then you'd say, okay, so now I can start doing some math here. There's just a problem with this. And by the way, now that I've moved stuff, let me change the origin to geometry because I messed with the geometry a bit. So normally now you could start to measure things in here. And what you will notice if I go to this measure tool here and I click here, oopsie, is that if I wanted to make this 60 meters, and I bring this up here, you can see it's only 1.5 meters and not even quite that, but let's say it's about 1.5 and we want it to be 60 because that's what we're given. So I've got to make this background image a lot bigger, and it would be multiplying what the background image is by whatever would make 1.5282 up to 60. So in this case, I'll take my calculator. This is all the setup, that you have to do, and I will say that 60 divided by 1.5282 is 39.2. So I can take this whole number. I guess that's better. I'll copy it. Why not? And then I'll take the actual background image. I need to go back. I'm in object mode now. Take this background image and scale it up by that amount. So put that in there and put that in there. And now I'm also going to have to scale up my triangle. And let's see if I scale that and scale that, and then move my triangle down to match it. So now when I go and measure, so let me see if I can get rid, oh, no, I don't want to get rid of that. Let me undo that. Right. So when I go to my measurements, here's my measure tool. I'm not sure, how to delete that measurement yet, because when I go to measure here and to here, you can see now that I am close to 60 meters. So there's my 60 meters, 59.7, roughly there's 60. So it's more or less the right size. This image here can be turned on and off. I also should be able to, let me call this the reference image. And now I also want to see if I can make it a little bit more transparent. So here's my opacity. Yeah. All right. So I can see things a little bit better. So yes, this here is about 60. So it works for, I don't want to spend too much time trying to make it exact because I want to show the principle. But what I want to do now is get this angle here. And so if I were to measure this plane and draw a line and then bend it like this, you can start manipulating this and bring it down with the measurement tool to get this angle. But look what happens. It actually is 32 degrees and not 22. And that is because whoever made this diagram was making an idealized diagram and not making any kind of real diagram. And that can really throw you. Or maybe that was done so that students wouldn't use a ruler and measure, maybe so that they would have to use the math. But the real 22 degrees would be out here. And that looks like a much different triangle. So now that we know that that is a 22 degree angle and with a 60 meter tall side, now we'd have to go back to our triangle here and go into edit mode and grab this vertex and move it along. Okay. So for checking work's sake, that's what I would use Blender for. That's the actual triangle being described in this with an angle of 22 degrees and a side opposite of 60. And then if you wanted to know, well, okay, what is the length of the other sides, and you'd calculated that with your math, then you could go and, oopsie, I need to get this back to 22, don't I? There it is. Right. Then to check your math, you could go and draw a line and somehow I've gotten this to be an angle rather than a, so I need to, yeah, and I still don't know how to, there we go, that's deleted it. But you can look and say, right, to measure this side, it should be something on the order of 158, 159, and you can look at this side and say this one should be somewhere in the range of 143 or so, and that's how you would use it to check things. You could also check the angle here, but of course this is just a right angle, so if I wanted to take this side, it's just that the tool here is a little bit kludgy, a little bit clunky. So there's 90 degrees, obviously, or something along those lines. And then what about this angle? You would draw your line, snap it like this, bring this down, and then you can get the other angle, which should be somewhere in the order of 67 degrees. Of course, that angle here was supposed to be 22, and that's why this is a mess. There we go. 22. So if you have a 90 and a 22, and of course you need to have these two add up to 90 because all three angles equal 180, and that means that this angle here, which I totally screwed up, should be 68. There we go, something like that. So I'm not saying that you would do the math in Blender. It just gives you some appreciation for if you got close to the values that you're supposed to when you do the trigonometry. That you do have this measuring tool over here on the left. As kludgy as it is, it can be used to measure angles and use visualizations. So for example, if we did another problem, and let's create a new scene, and I still have to figure out how do you get rid of these marks, because when you go back to the marks, they all show up. And I guess you click on it, can you, yeah, I guess you have to click on it and then delete it, click on it and delete it, click on it and delete it. So a bit of a pain. Click on this one, delete it, click on this one, delete it. It's not letting me, there, click on it, delete it, and click on this and delete it, and click on this and delete it. Okay, so we have that. Let's go on the internet and let's look at trigonometry problems. Trigonometry word problems.
Is it okay if I put
Okay, let's look at images. And here's a typical one here, or here, or here. So if you have something like this, typical one, let's save the image in our math problem images and call it math problem 2. All right, and then go back to Blender and add the image for reference. And there's math problem 2. And there it is. So once again, the procedure would be that we need 100 feet here, and this tower is not 100 feet. So go to your measuring tool and measure the height, which is 1.198. And then what you would do is you would go to your calculator and you'd say clear 100 divided by 1.198, and that gives you 83 and change. And then go to this diagram, which will be our math image, and go to your scale and put in that scaling factor that we just came up with. Now you have from here down to here approximately 100 feet. It's a little bit more. Again, I'm not going to worry about that right now. Let me, got rid of that by mistake. I'm still trying to figure out how to get rid of little lines like this. There we go. All right, so now we can draw our triangle again by adding a plane and then scaling that plane up. And then going to edit mode, picking these 2 points and adding connect vertex pairs, then taking this vertex and deleting it. That gives me a triangle. Then I can take this and move it on the x-axis to here, and take this vertex and move it down in the y-axis to here, and take this vertex and move it in the x-axis to here. Check where that is. It's at this value here. Copy that. Go to this vertex here, since this is a right triangle, and put that in. Okay. And then, of course, this vertex here needs to be grabbed and brought up in the y until it matches. This one here needs to be moved in x till it matches. Let's go to wireframe mode. And what they're hoping, we know that this is now approximately 100. Let's see if their diagram is right. And so the angle that we would measure, we would draw a line and then break it up, move that there, go to the top of the line and move that there, and move this one like this. It says it's 20 degrees and not 25. So 25 would actually be right here. Isn't that interesting? So always these diagrams are off. That would be 25 degrees. So then you go into your plane. I'll call this my triangle, and grab that vertex and move it. That triangle there is the actual 25-degree one. Now, obviously the way you're supposed to calculate the distance here of x by using SOHCAHTOA, if you remember that, SOHCAHTOA is sine equals opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And so here we know what the opposite is, and we want to find out the adjacent. So it says 100 feet is the opposite, and x is the adjacent, and so you'd use tangent for this, and it'd be tangent of 25 degrees equals opposite 100 over adjacent, which is x. And then you'd find out, you'd calculate the tangent. And so let's do that. We'll say tangent 25 equals, and that's the value in radians. Except it's supposed to be tangent of 25 degrees. 5 degrees, there we go. And it's 0.466307. So we have that value, and we say we want 100 over 0.04. So we have to say, clear this, and say 100 divided by, and then put our value in, and we get 214.45. This is where we then use Blender to check our work, because if we measure from here, let me get out of here. If we measure from here to here, we're seeing interesting. So it says 227, and our calculator is saying 214. So obviously there's something wrong there. If we draw this out, it would be a lot longer. 214 would be somewhere about here. So for some reason, my diagram isn't working. Maybe because the tower isn't exactly 100. That is quite possible. So when I draw a line from here to here, yeah, it's significantly greater. It's 107. So let's figure a way around that. Let's go to take this point here, and it is in the y-axis. You'd have to move the whole diagram over to 0. So let's think this through. What if we were to take, so here's another way to do it. We can go into object mode, and because we've got this like this, let's go and make our transparency. Let's just take these objects. We'll deal with this math later. Still working out the best way to do this. Let's go into this diagram here and change its opacity so we can see the grid that's behind it. Let me then move this so that on the 0 point we have the diagram. Okay, let me then move this here. And let me make sure that I put the origin to the geometry. Now let me take this edit mode side, place this vertex of y at 0. That didn't work. In global. There we go. I was in local, to be in global. And this one here, then, if this is at 0, then this one should be at 100, not 109. that was the problem. So even this diagram is very messed up in that way. But we'll get the idea. And then this vertex here, we should still be getting the 25 degrees. And so let me get rid of that. Let me get rid of this. And let me get rid of this now. If I can. Oh, there we go. Right. And let me do my measurement and say, well, if I go from here and then break it, go, whoa, not that, and then take this and bend it like that, and then bend this, so that isn't 25. So 25 is now over, assuming I had this right. And this is the problem, is knowing when you're actually on this. All right, so 25, it's more like that. And then I've got to then go to the triangle. Oops, I want to keep that on. Grab this vertex and move it in X. Like that. And then let's see what the measurement looks like. Now if we go from here, parallel to it, here to there, 214. Yeah. All right, so being able to visualize in Blender is the idea when we want to teach it. Knowing that the diagrams that are found online do not conform to reality, but being able to show students that you can create the geometric figures and you can measure them to see if you've made any errors, whether the angle was an error. But it got just the tendency to take a ruler and just try to measure. That's probably why they don't make these diagrams perfect. But I like Blender for checking our work. I think that's very useful. And in future, I'm going to figure out how to use the Python scripting area to get some information so we can check the actual math, because Blender should be able to do that. In fact, what if I go now to...
Daddy,
yeah.
high five.
You did?
High five, Daddy.
High five now. Thank you. So I'm going to ask ChatGPT, what Python formula can I use in Blender to check the tangent of a triangle and see I wonder if this will work. Never tried this before. So copy code,
Daddy, I've got some
go
frozen
into Blender.
jackfruit.
Really?
Yeah.
What a new.
Do you want to come
Paste
and
that
eat
in.
it with me?
Not sure, Nye.
But you like frozen fruit.
I do. And
You
I've
want
never
to
done this,
eat
so I have to
it?
figure out.
You
No
want
thanks.
to eat frozen fruit?
No thanks. So let me see what
You
it's
want
also
to
telling
eat
us.
jackfruit. Jackfruit
Replace
tastes
the vertices with the vertices
Daddy,
of your triangle.
jackfruit tastes like frozen mango.
Mm-hmm.
Want to try some?
No thanks. Replace the vertices. Alright, something I'll need to look up now that my son is messing with the frozen mango. So we'll pause here, just knowing that that is the next item on our agenda, is to use the scripting function in Blender so that we can check some of the math as well. All right.